Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for May-June 2020, and the code is 9709/31. So let's get started. For question number 1, find the set of values of x for which this inequality. Give your answer in a simplified exact form. So first of all, I will rewrite the question. To get the x, since the x is the power of the number, alright, so the base 3 and base 5, then to solve this question, we will have one method, which is by using ln. Okay, so which is a natural logarithm. Then I will just take one ln both sides. For the left hand side, you have ln of multiplication of two terms. So for this case, we will be using the formula ln AB equals to ln A plus ln B. So this will be simplified into ln 2 plus ln 3 to the power of 1 minus 2x is less than ln 5 to the power of x. Okay, and again, the second term on the left hand side, the x is still the power of 3, so I will move it down, okay, by applying a formula. Same goes to the right side. Okay, so the formula is going to be ln A to the power of B. It will be B ln A. So that means I will be getting ln 2 plus 1 minus 2x ln 3 less than x ln 5. So then from here, I will just do expansion for the second term on the left hand side. So it will be ln 2 plus 1 times ln 3 is ln 3 minus 2x ln 3 less than x ln 5. So the x will be grouped together, which means I will move this minus 2 ln x minus 2x ln 3 to the right hand side. So again, for the left hand side, you will have ln 2 plus ln 3. Then this one can be simplified later on. So less than x ln 5 plus 2x ln 3. Then from here, for the left hand side, since you have summation of 2 ln, then we can just apply the first formula, which is multiply the two numbers. Then you'll be getting ln 6. 2 times 3 is 6. Less than factorize the x. Then it will be ln 5 plus 2 ln 3. Excuse me. Okay, so now since we need to get exact form, okay, so from here I will get ln 6 less than x bracket. This is basically ln 5 plus ln 3 squared, okay, by using the second formula here. So ln 3 squared is 9. This is plus ln 5. That means again using the first formula, when you combine both summation, the summation of two terms, that means you'll be getting multiplication. So I will get ln 6 less than x times ln 5 times 9. Then I will be getting ln 6 less than x ln 45. So at last, the ln 45 will be moved to the other side. So which means x is greater than ln 6 over ln 45. So this is the exact value. Okay, next question, 2a. Expand 2 minus 3x to the power of negative 2 in ascending powers of x up to and including the term in x squared, simplifying the coefficients. So 2 minus 3x to the power of negative 2. We have a formula here, which is 1 plus x to the power of n, whereby the n is any real numbers or any real numbers. It will be 1 plus nx plus n times n minus 1 over 2 factorial x squared. So the conditions for using this is, here is 1, the first one is 1 and then followed by plus. So now by looking at the question, we have 2. Therefore, we must factorize the 2, or before that I will write 2 plus negative 3x power negative 2 first. Then from here I will factorize 2. So once I factorize 2, I will get 1 plus negative 3 over 2x, then to the power of negative 2. Okay, and then now the next step is consider the degree of minus 2. So it will be 2 power negative 2, then 1 plus negative 3 over 2x, the whole term with degree negative 2. Okay, so 2 power negative 2 is 1 over 4. And now we can just use the formula. Okay, 1 plus x. So this is 1 plus, this is my new x. So then my n will be negative 2. So now you will be getting 1 plus negative 2 times negative 3 over 2x. This is my new x. Plus n is minus 2. N minus 1 is minus 3 over 2 factorial. Then negative 3 over 2x squared. Okay, because as requested, you just need to get the expansion up to x squared. Then from here, you will be getting 1 over 4. Then it will be 1 plus 3x. Then plus 27 over 4x squared. Okay, at last, you will be getting 1 over 4 plus 3 over 4x plus 27 over 16x squared. So these are the three terms in your expansion. Okay, B, state the set of values of x for which the expansion is valid. So for your information, the expansion will be valid, right? This expansion is valid when modulus of x is less than 1. Okay, so same goes to this expansion right now. So we will take modulus of this new x be less than 1. Okay, so then I will be getting modulus of negative 3 over 2x less than 1. So after the modulus, it will be positive 3 over 2 modulus x less than 1. Okay, then at last your modulus x is less than 2 over 3. So this will be the set of x for which the expansion is valid. Okay, now question 3. Express the equation tangent theta plus 60 degrees equals to 2 plus tangent 60 degrees minus theta as a quadratic equation in tangent theta, and hence solve the equation for 0 to 180 degrees. So now we have two terms, right? This is tangent of summation of two terms. So we have to refer to this formula, tangent A plus B. It will be tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, so by applying this formula, you will be getting tangent theta plus tangent 60 degrees over 1 minus tangent theta times tangent 60 degrees. That is our left hand side. Then for the right hand side, it will be 2 plus. Now, tangent 60 degrees minus theta, when it is minus, you change this to minus, and here is plus. Okay, so the denominator you have to change to plus. So it will be just opposite sign. It will be tangent 60 degrees minus tangent theta divided by 1 plus tangent 60 degrees tangent theta. Okay, so for your information, tangent 60 degrees is square root 3. So here becomes tangent theta plus square root 3 over 1 minus square root 3 tangent theta. So for the right side, it will be the same. Tangent 60 degrees is square root 3. Then minus tangent theta over 1 plus square root 3 tangent theta. Okay, so in order to get the quadratic equation in tangent theta, right, I will get the same denominator first for the right hand side. That means I will just times 1 plus square root tangent theta to 2. Okay, so it will be 2 plus 2 square root 3 tangent theta. Then now, when I times it to the 2, that means the 2 will be having the same denominator. So this means I will just rewrite the denominator and combine with the existing terms. Right, so here you will be getting plus square root 3 minus tangent theta. Alright, then for the left hand side, you can just rewrite now. The next step is you just cross multiply. Okay, so because we need to get the quadratic equation, so I will cross multiply. So I will get tangent theta plus square root 3 multiply with 1 plus square root 3 tangent theta for the left hand side. And then for right hand side, this 1 minus square root 3 tangent theta will move up. So 1 minus square root 3 tangent theta. And for the numerator here, I can simplify these two terms. Okay, means that I factorize the tangent theta. The rest just rewrite. So I will be getting 2 plus square root 3. Okay, first and third term. Then tangent theta will be taken out. After that, 2 square root 3 minus 1. Because we have factorized the tangent theta from the second and fourth term. Okay, and now we will just need to do the expansion. So when you do expansion, okay, you will be getting tangent theta plus square root 3 tangent squared theta. And then square root 3 times 1 is square root 3. Square root 3 times square root 3 tangent theta is 3 tangent theta. Okay, so for the right hand side, just 1 times all these terms and then followed by square root 3, negative square root 3 tangent theta times the whole bracket. So when I times by whole term, I times the whole bracket by 1, we just need to rewrite. So it will be 2 plus square root 3 plus tangent theta 2 square root 3 minus 1. And then for the second expansion, which is this, right, then you will be getting the minus 3, okay, minus square root 3 times 2. So it will be negative 2 square root 3 tangent theta. Then the minus 3 tangent theta times the square root 3. Minus square root 3 tangent theta times square root 3. It will be minus 3 tangent theta. Okay, then this tangent theta multiply with tangent, it will be tangent squared. And then this negative square root 3 multiply with 2 square root 3, it will be negative 6. Right, so I will get negative 6 tangent squared theta. And then lastly, this whole term you multiply with tangent first, which is tangent squared. Alright, and then this term multiply with minus 1, that means it's plus square root 3 tangent squared theta. Alright, so now I will just do expansion and simplify all the terms. So for the left hand side, we look at the left hand side, tangent, 3 tangent, it will be 4 tangent theta. So I will rewrite first, square root 3 tangent squared theta plus 4 tangent theta, then plus square root 3. For the right hand side, okay, I will get 2 plus square root 3. Then this one you do expansion, it will be plus 2 square root 3 tangent theta minus tangent theta. Then again, minus 2 square root 3 tangent theta. Then here minus 3. Okay, then minus 6 tangent squared theta. I just rewrite the rest of the terms. Then from here, I will try to simplify the terms on the right hand side. So the third term and fifth term will be cancelled off. Okay, then I will move all the terms to the left hand side. So here I will be getting square root 3 tangent squared theta plus 4 tangent theta plus square root 3. Then when I move the all the terms on the right side to the left side, I will be getting minus 2 minus square root 3, or you have to change the sign. Then the minus tangent theta becomes plus. Then here, okay, here is plus 3 tangent theta plus 6 tangent squared theta minus square root 3 tangent squared theta equals to 0. So now we need to get the quadratic equation. So from here, I can simplify first and last term. I can cancel off. Then here, followed by, okay, 4 tangent theta plus another 4 tangent theta, it will be 8 tangent theta. And don't forget, there is a 6 tangent squared theta here. That means I will be getting 6 tangent squared theta, then plus 8 tangent theta. Then for the constants, square root 3 and minus square root 3 cancel off. Then I only have minus 2. That means here, minus 2. And we need to simplify it. Therefore, divided by 2, it will be 3 tangent squared theta plus 4 tangent squared theta minus 1 equals to 0. So this is our quadratic equation in terms of tangent theta. Okay, now according to the question, hence solve the equation for 0 to 180 degrees, which means now, hence means use this last answer. So I will rewrite first our theta from 0 to 180 degrees. Okay, both inclusive. Okay, which means now I have to simplify this quadratic equation. So this quadratic equation cannot be factorized. Therefore, I have to list down my A is the coefficient for tangent squared, which is 3. My B is 4. And then my C is minus 1. Now you use the quadratic formula to solve this, which means ax squared plus bx plus c equals to 0. Then the x is going to be minus b plus minus square root of b squared minus 4ac over 2a. Okay, so then from here, I will be getting tangent theta equals to minus 4 plus minus square root of 4 squared minus 4, a is 3, c is minus 1 over 2a. Then here you will be getting 0.2153 and negative 1.5486. Okay, and now we need to get the theta value. So what I need to do here is I will just continue this side. So tangent theta is positive and negative, which means the first value will be in first quadrant because tangent is positive, and then the second value will be in the second quadrant. Now I need to find these two values. So when you consider inverse tangent 0.2153 in degrees, it will be 12.2 degrees. Okay, so inverse tangent of 1.5486, it will be 57.1 degrees. But for the second angle, it will be the major angle here. Right. This is our angle. That means from here, I will be getting theta is 12.2 degrees, and another one is 180 degrees minus 57.1 degrees. So at last, you will be getting theta is 12.2 degrees and also 122.9 degrees. So that's the solution of this question. Okay, question number 4. The curve with equation y equals to exponential 2x times sine x plus 3 cos x has a stationary point in the interval 0 to pi. When you see stationary points means dy dx equals to 0. Now A, find the x coordinate of these points, giving your answer to 2 decimal places. So your y is e2x times sine x plus 3 cos x. So when dy dx means that this is the product rule. So it means this is u and the v is the bracket. So now according to the product rule, d over dx uv. it will be uv prime plus vu prime. Okay, so now I will write down all this first. So your u is e2x, your u prime is e2x, and then differentiate 2x is 2. Okay, that is the differentiation of exponential function. So your v is sine x plus 3 cos x. Then the v prime is differentiate sine, you get cos. Differentiate cos is minus sine. Then now your dy dx is going to be uv prime. So exponential times the cos. So I will rewrite this. Dy dx equals to exponential times the v prime. So cos x minus 3 sine x plus vu prime. So means that sine x plus 3 cos x multiplied with 2e 2x. Okay, so from here, I can factorize the common term, which is the exponential 2x. Then you will be getting cos x minus 3 sine x. And then for the second term, once we have factorized the exponential, you still have the 2. So this 2 must multiply to the remaining terms. Then you'll be getting 2 sine x plus 6 cos x. So now simplify the terms inside the bracket. Cos x plus 6 cos x, 7 cos x. Minus 3 sine x plus 2 sine x, it will be minus sine x. Okay, now since stationary points means dy dx equals to 0, now I need to let dy dx be 0 to get the x. Okay, correct to 2 decimal places, which means now e2x times 7 cos x minus sine x equals to 0. And we know that exponential function cannot be 0. Therefore, 7 cos x minus sine x must be 0. Okay, because for any exponential graph, it will be above the x-axis. So this is your exponential x. Right? So we need to solve 7 cos x minus sine x equals to 0, which means 7 cos x equals to sine x. Then I divide the whole equation by sine, okay, by cos, because we know that tangent x is sine x over cos x. So I divide by cos x, 7 equals to tangent x. Okay, so which means now your x is inverse tangent 7, and from here your x is defined from 0 to pi. That means you must use the radians mode in your calculator. Okay, so your x will be inverse tangent 7, that will be 1.43 radians. So that's the solution of this question. Okay, B, determine whether the stationary point is a maximum or minimum. So to get the maximum or minimum, we need to differentiate second time. Therefore, I will rewrite my dy dx. So my dy dx just now was e2x times 7 cos x minus sin x. Okay, so now to get the second derivative, again, this is multiplication of two terms. That means we have to use the products rule. My u is going to be e2x. Okay, so then my u prime will be 2e2x as just now. So then the v is 7 cos x minus sin x. So then the v prime differentiate 7 cos x, negative 7 sin x. Differentiate negative sin x is negative cos x. So from here, when I use the formula, I will get u v prime, which is e2x times minus 7 sin x minus cos x plus u prime v. Okay, so I have not enough space, therefore I will just write on the next line. So it will be 2e2x multiplied with 7 cos x minus sin x. Then from here, the common term is e2x. So you can just factorize e2x and rewrite the rest of the terms. So be careful with the second term here. Once you have factorized the e2x, you still have the 2. So this 2 must multiply to all the terms inside the bracket. Again, you get plus 14 cos x minus 2 sin x. Then at last, you will be getting minus 9 sin x plus 13 cos x. Okay, so to determine whether it's a maximum or minimum point, look at the x here. So this x must be substituted into your expression for the d squared y over dx squared. So I will replace the x by 1.43. Right, so at x equals to 1.43, the d squared y over dx squared is going to be e2 times 1.43 multiplied with minus 9 sine 1.43 plus 13 cos 1.43. So remember to calculate all this using radians mode. So it will be negative 123.7434, and now we always round up to 3 significant figures, that is negative 124, which is less than 0. So when the second derivative is less than 0, which means the stationary point is a maximum. Okay, it's a maximum point. So that is the solution of this part. Okay, next question 5a. Find the quotient and remainder when the cubic function is divided by x squared plus 3. So this can be done using polynomial division. So I will use polynomial division. 2x cubed minus x squared plus 6x plus 3 divided by x squared plus 3. So a term multiplied to x squared to get 2x cubed, that term must be 2x. So here 2x times x squared, it will be 2x cubed. 2x times 3 plus 6x. And now minus. So minus x squared minus 0. You will get minus x squared. Bring down the plus 3. So in order to get this minus x squared from x squared, I need to times by minus 1. So therefore you will be getting minus x squared minus 3. Okay, first term will be 0. Second term, 3 minus minus 3 will be 6. Therefore, from here, our quotient equals to 2x minus 1. And then the remainder is 6. Okay, so done for the 5a. Okay, now B, using your answer to part A, find the exact value of this this integration. So we will just use the quotient and remainder that we have found in previous part. This is going to be integrate 1 to 3, 2x minus 1 plus 6, because the remainder is 6 just now. Okay, 6 over the divisor. The divisor is x squared plus 3. So I will split into two integrations. The first is integrate 1 to 3, 2x minus 1 dx. And the second integration is I factorize the 6. Then I will change it to x squared plus square of square root 3. Okay, then I will apply the formula. Integrate 1 over a squared plus x squared dx is going to be 1 over a inverse tangent x over a plus c for the second integration over here. So this is square root 3. Right, which means my a is basically square root 3. Okay, then now for the first term, I will be using another formula. Integrate ax plus b to the power of n dx. It will be ax plus b to the power of n plus 1 over n plus 1. And then differentiate ax plus b is a followed by plus c. Remember, this formula is only valid when the n is not minus 1. That means now I will be getting 2x minus 1 to the power of 2 over 2 first. The 2 comes from the degree, and then when you differentiate 2x minus 1, you will be getting another 2. Okay, so since both integrations with same limits, I will combine the limits later on. So then the next one is going to be plus 6. So the whole integration, it will be 1 over square root 3 inverse tangent x over square root 3 together with limits 1 to 3. Okay, so from here, when you simplify, right, or you can just substitute the x directly. So now when I replace the x by 3 here, 2 times 3 is 6. 6 minus 1, it will be 5. 5 squared, right, if I write step by step, 5 squared over 4. Then the next one is going to be 6 over square root 3 inverse tangent 3 over square root 3, which is square root 3, minus when the x is replaced by 1. So 2 times 1 is 1. 2 times 1 is 2. 2 minus 1 is 1. So 1 squared over 4. Then plus 6 over square root 3 inverse tangent 1 over square root 3. Okay, then from here, you will be getting 25 over 4 plus 6 over square root 3 inverse tangent square root 3 minus 1 over 4, then minus 6 over square root 3 inverse tangent 1 over square root 3. Now, when you calculate the value, this will be, alright, when you simplify, 25 over 4 minus 1 over 4 is 24 over 4, which is 6. Then the second term, 6 over square root 3 inverse tangent square root 3 is basically pi over 3. Okay, then minus the same term. Inverse tangent 1 over square root 3 is pi over 6. Then now I will just simplify 6 plus. Okay, so from here you can factorize, or you can factorize 6 over square root 3. So pi over 3 minus pi over 6. Okay, so pi over 3 minus pi over 6, you will be getting pi over 6. Then the 6 will be cancelled off, and at last you will be getting the simplest form. So here is going to be 6 plus pi over square root 3. So that's the solution of this integration. Okay, next question, number 6. The diagram shows a circle with center O and radius R. The tangents to the circle at the points A and B meet at T. So tangent means here both are 90 degrees. And the angle AOB is 2x radians. The shaded region is bounded by the tangents AT and BT and by the minor arc AB. The area of the shaded region is equal to the area of circle. So now show that x satisfies the equation tangent x equals to pi plus x. So we need to show this using this statement. Alright. So now area of the circle. Okay, area of the shaded region. So from here I will say that it is basically AOBT consists of two triangles. Okay, the triangle will be AOT. Right, it will be the same for both triangles. So that means from here, I need to know what is my area, what is my AT first. What's my AT? So that I can find the area of triangle, then I times 2. That will be the area of the whole AOBT. So when you look at this triangle, that means here is going to be x. Right, so this AT is the opposite side of the x, and the R is the adjacent side. So you have opposite and adjacent, that is the tangent. So I will just write tangent x equals to AT over OA. Okay, opposite over adjacent OA. So now I need to know what is my AT. So now my AT is OA tangent X. And my OA is basically R, is given in the question. So that means this is R tangent X. That is my AT. Then now I will just write area of triangle AOT equals to half of OA times AT. Okay, because that is the base. AT is the base and then OA is the height. So it means that it will be half R tangent X, because my AT is R tangent X. That means here you'll be getting half R square tangent X. So since you have found the area of the triangle, which means now we can find area of the whole diagram. AOBT is double of the triangle. So now from here, I will write area of AOBT is double of area of the triangle, which means this is going to be R squared tangent X. Right? And now, we need to find what is the area of the sector here so that you can find the shaded region. So for your information, if let's say this is the R, here is the theta, area of the sector, it will be half R squared theta. That means now our angle is 2x, right? So your theta becomes 2x. The R remains. So I will get half R squared times 2x. So that means now here, area of minor sector AOB is half R square 2x, which is R square x. Okay, so now I can find the area of the shaded region by using area of AOBT minus the area of the sector. That will be my area of the shaded region. So then I will just write area of the shaded region equals to, because it's given in the question here, equals to the area of the circle. So here, area of the circle. That means here is going to be R squared tangent x, okay, which is here, minus R squared x. That equals to area of circle is basically pi R squared. So pi R squared. So from here, all the R squared can be cancelled off. Okay, and then you will be getting, now let's look at the question. You need to show tangent x equals to pi plus x. So from here, I will get tangent x equals to pi plus x. So shown. Okay, so that's the solution for first part. Now B, this equation has one root in the interval x between 0 and half pi. Verify by calculation that this root lies between 1 and 1.4. So just now we got tangent x equals to pi plus x. So I will move all the terms to the left side now. So that means tangent x minus pi minus x equals to 0. And now I will let this be fx. Then replace x by 1 and 1.4 to show that there is a change, sign change. And calculate this using radians mode, then you will be getting negative 2.58 correct to 3 significant figures. And for f1.4, it will be tangent 1.4 minus pi minus 1.4. Then you will be getting 1.26, which is greater than 0. And now you just write, since f1 less than 0 and f1.4 greater than 0, there is a sign change. Hence, the root lies between 1 and 1.4. Now see, use the iterative formula to determine the roots equal to 2 decimal places. Give the answer of each iteration to 4 decimal places. So now, because we know that the x lies between 1 and 1.4, so I will get the midpoint of this. You can let x not be 1 or 1.4, any numbers. So I will just take the midpoint. So it means that xn plus 1 equals to inverse tangent pi plus xn. So I will let x not be 1.2, which is a midpoint. So x1 will be inverse tangent pi plus 1.2. Then you will be getting 1.3444. Okay, so now continue for the next calculation. This is going to be pi plus 1.3444. Inverse tangent of this value will be 1.3515. Okay, so your final answer 2 decimal places. Make sure you get these 2 same decimal places. But then unfortunately they are not the same. Therefore we need to continue for next calculation. Then here is going to be 1.3518. And then now you are getting the same value. Okay, that means we can just stop the iteration and write down the conclusion. So it is 1.35 because the next value is just 1. So we just ignore the 1. Okay, so this is part C. Now next question 7. Let fx equals to cos x over 1 plus sin x. Show that f prime x less than 0 for all x in the interval x between negative half pi and 3 over 2 pi. So now, to get this differentiation, we need to apply the quotient rule. That means d over dx u over v is going to be v squared in the denominator, then vu prime minus uv prime. Okay, so now my fx equals to cos x over 1 plus sin x. My u is cos x. My u prime is negative sin x. Then v is 1 plus sin x. The v prime is cos x. So now f prime x, according to the quotient rule, that will be 1 plus sin x squared. Then the numerator is 1 plus sin x times differentiation of cos x, which is a u prime, you get negative sin x. Minus, keep the cos x and v prime. V prime is cos x. Okay, so from here, just do expansion. You will be getting negative sin x, negative sin square x, then negative cos square x over 1 plus sin x squared. Now, for the cos square x and sin square x, both are negative. I can just take out the negative. Then now we have an identity. Cos square x plus sin square x is 1. Okay, that means this is going to be 1. Then now I still have minus for both terms, so I will just factorize the minus. Then I will be getting sin x plus 1 over 1 plus sin x squared. So then the 1 plus sin x will be cancelled off. Then you will get negative 1 over 1 plus sin x. Okay, now you need to show that it is always less than 0 for the x between minus half pi and 3 over 2 pi. So now I have to sketch a graph. Okay, this is your sine. Here is 3 over 2 pi. This is half pi. This is pi, and here is half pi. But then since your interval is from minus half pi to 3 over 2 pi, that means now I have to extend this graph. So here is negative half pi. Alright, so from here, I know that within this interval, your x will be between minus 1, and your sin x will be between minus 1 and 1. Okay, so I will just explain over here. Minus half pi to 3 over 2 pi. The sin x will be between minus 1 and 1 according to the graph. Okay, so here I have 1 plus sin x. So 1 plus sin x, when you plus 1 to the inequality, I'll get between 0 and 2. Okay, and then there is a 1 over. So when I consider 1 over, right, so 1 over 0, when you take 1 over 0, we don't write 1 over 0, but it will be infinity. Okay, so that means this is less than half and this is infinity. So here more than half, and then more than infinity. Alright, 1 over 0. We will not get exactly 1 over 0, but it close to 0. So then from here, there is a negative here. That means when I times a negative to the inequality, you have to change the sign. Right. So okay, let me check one more time. Alright. Okay, so here I will write less than z. This is when you consider 1 over, right? 1 over 0 is infinity. It's still positive. That means I will write it is still greater than 0. Okay, so here will be 0, then this is half. Right, so when I times a negative, then I will change the sign. So that means it will be 0 here. Right, this is negative half. That means your fx is greater than negative half, but then it's less than 0. So, in other words, you can just write your fx is greater than negative half, but it's still less than 0. Okay, according to when you read from the right side, I mean in this direction. So, from here, in general, your fx is still less than 0. So, therefore, not fx, this is our f prime x. Okay, this is our f prime x. So I will write here f prime x. This is f prime x. So, in other words, f prime x is less than 0 for theta, the x between minus half pi and 3 over 2 pi. Okay, so that is how we prove the f prime x less than 0. Okay, B, find the integration. Give your answer in the simplified exact form. So, when I integrate pi over 6 to pi over 2 fx dx, so it becomes cos x over 1 plus sin x dx from pi over 6 to pi over 2. So this can be solved using ln, because we have a formula: integrate f prime x over fx dx is ln fx plus c. Right. So when we differentiate 1 plus cos x, 1 plus sin x, you are getting cos x directly. That means this is going to be ln of 1 plus sin x. Then the limits, just rewrite the two limits. And now you replace the x by sin x first. So I'll get ln 1 plus sin x. I put a modulus here to make sure that it is a positive value. If you are sure that it is positive, then you can just use bracket. Then minus ln 1 plus sine pi over 6. Then here is going to be ln. Okay, the limits is pi over 2. Alright, I wrote wrongly. This is 2. So sine pi over 2 is 1. So 1 plus 1 is 2. So minus ln 3 over 2. Because ln pi over 6, sine pi over 6 is half. Right. So now we have both ln, and it is minus. Therefore, I will have ln A minus ln B, which is ln of A over B. Then now you just divide. This will be ln of 2 divided by 3 over 2. So at last, you will be getting ln of 2 times 2 over 3. Then it will be ln of 4 over 3. Okay, that's the solution of this question. Now question 8. A certain curve is such that its gradient, so gradient is dy dx, is proportional to y over x square root x. The curve passes through the points with coordinates 1, 1 and 4z. By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. So now dy dx proportional to y over x square root x. So when proportional, you change to equal sign, but you must times by a constant, which is the k. So I'm getting this expression now. So replace 1, 1. Oh, sorry. Before we replace 1, 1, we have to solve this differential equation first. Okay, so we have solved it. Now we have set up the differential equation, and now we need to solve it. So since the dy is numerator, therefore the y will be on the left side. I will be getting 1 over y dy equals to k times 1 over this x square root x is basically x to the power 3 over 2. Then dx. And now I integrate both sides. So now for the right hand side, I have to move up the x and factorize a k because k is a constant. And now for the left hand side, I will integrate using the ln. Differentiate y is 1. Okay, therefore left hand side is ln y. Right hand side we use the formula. So integrate x power n dx, it will be x to the power of n plus 1 over n plus 1 plus c. Right? So then from here, you just plus 1 as long as the n is not minus 1. Then this formula works. That means here you will get k bracket x to the power of negative 3 over 2 plus 1 is negative half. Then over negative half. Then you plus c. That means here is going to be negative 2k x to the power of negative half plus c. And now I will simplify it. So the negative half, the power of negative half, you can just bring it down. Therefore, it will be negative 2k over square root x. Okay, and now to get the k and c, replace the 2 points. Okay, substitute the 2 points, 1, 1 and 4e. So I will replace the xy by 1, 1 first. That means ln 1 is negative 2k over square root 1 plus c. So which means ln 1 is 0. Right. So here is 0. Then I will be getting c equals to 2k. That is the first equation. The second point for e, so it will be ln e equals to negative 2k over square root 4 plus c. So now ln e is 1. So square root 4 is 2. So minus 2 over 2 means that you are getting minus k plus c. Okay, so this is our second equation. Now I will substitute first equation into second equation. That means now 1 equals to negative k plus the c is 2k. That means k equals to 1. Okay, now from the first equation, I found that my c is 2k. That means it's 2 times 1, which is 2. So at last, I will just substitute back into this expression. You will get ln 1 equals to, ln y equals to negative 2k over square root x. So your k is 1. That means it's negative 2 over square root x plus c means plus 2. Okay, and now let's look at the question. Expressing y in terms of x means to get the y as a subject, we need to take e both sides. Because we have a formula here. E ln a is a. Alright, so I will take e both sides. So e ln y is e negative 2 over square root x plus 2. So e ln y, at last you get y. Then the right hand side you just rewrite. So it will be 2 minus 2 over square root e. E to the power of 2 minus 2 over square root x. So this is our solution of this question. Okay, now next part, describe what happens to y as x tends to infinity. So I rewrite my solution. Y is e 2 minus 2 over square root x. So when x tends to infinity, okay, 2 over square root x will tend to 0. That means my y, okay, so that means my y will tend to e squared. Okay, so that's the solution for part B. Now, for question 9, with respect to all the vertices of triangle ABC have all these position vectors, using scalar products show that angle ABC is right angle. So let's say here is ABC. To show that it is right angle means that the scalar products equals to 0. Okay, so I have to refer to vectors BC and BA. So which means BA will be OA minus OB. So my OA is 2i 0j 5k minus OB is 3 2 3. Then you will be getting 2 minus 3 is minus 1, then minus 2 and 2. Now next is to get the vector BC. So vector BC is OC minus OB, which means you will be getting 1i 1j 1k OC minus 3 2 3. That is my vector OB. Then from here, you will be getting minus 2, minus 1, minus 2. Okay, these are the three vectors. These are the three components. Then now use a scalar products formula, BA dot BC. So it will be minus 1, minus 2, 2 dot negative 2, negative 1, negative 2. So then from here, just do the multiplication. Right, just multiply and plus all together. Make sure it is 0. So it will be minus 1 times minus 2 plus minus 2 times minus 1, then plus 2 times minus 2. So the first one is 2, second is 2, the third is minus 4. At last you get 0. Then you can just write angle ABC is a right angle, because the scalar product is 0. Okay, now show that ABC is isosceles. Isosceles means that you get two equal length. Alright, so now let's say we know that angle ABC is right angle. Here is ABC. Now I need to find what is my AC, because we have found the AB and BC just now. So vector AC is OC minus OA. So OC 111 minus 205. Okay, so 111 minus 205. Then here you will be getting minus 1, 1, minus 4. Then now we need to find the length. So length of AC equals to square root of minus 1 squared based on the vector here plus 1 squared plus negative 4 squared. Then you get square root 18. Now magnitude of AB refer to the previous calculation. So AB is same as BA. So means that minus 1, 2, or minus 1, minus 2, and 2. So here is going to be minus 1 squared plus minus 2 squared plus 2 squared, which is square root 9. Then I will get 3. So same for the BC, the length. So vector BC, we have found minus 2, minus 1, minus 2. So take the magnitude. And again, you are getting square root 9, which is 3. So here we only get two same length. Therefore, just write since AB equals to BC, means these two are referring to the length, then the triangle ABC is isosceles. Okay, so that's the solution of this question. Now C, find the exact length of the perpendicular from O to the line through BC. So now we know that this is our BC. Okay, let's say this is O, and then you need to find what is the length from O to BC. Let's say this is a P. So you need to find what is OP. Okay, so now line BC, I will write R equals to OC plus TBC. So now my OC is 111. Okay, my BC already found just now, -2, -1, -2. So from here, I will be getting 111 plus T, -2, -1, -2. Now for the right hand, the second vector, since all negative, I can take out the negative and I change the T to S. Means that my S is -T. Okay, so from the diagram, we know that OP is perpendicular to BC, right? That means OP, see, OP, the P, I would say P lies on the line BC. That means the OP is RBC. Okay, so OP is basically just combine all this. It will be 1 plus 2S, 1 plus S, 1 plus 2S. That is my OP. Then from here, since they are perpendicular, so OP dot, this is the vector, this is the direction vector BC. So dot BC equals to 0. Okay, so now just rewrite 1 plus 2S, 1 plus S, 1 plus 2S, multiply with the BC minus 2 minus 1 minus 2, then equals to 0. Then now, when we do expansion, the scalar products of these two terms, you will get -2 times 1 plus 2S minus 1 times 1 plus S plus -2 times 1 plus 2S equals to 0. Then from here, you will get -2 minus 4S, -1 negative S minus 2 minus 4S equals to 0. Then you will be getting -9S minus 5 equals to 0. Hence, your S is -5/9. Okay, once you have found this, because we need to find the length of OP, therefore, we have to find the vector first. So substitute the S. So now your vector OP equals to 1 plus 2S. Okay, then 1 plus S, and then 1 plus 2S. Then from here, you will be getting -1/9, 4/9, and -1/9. So now the length, okay, the length, which means is the magnitude of the OP, that is going to be square root of -1/9 squared plus 4/9 squared plus -1/9 squared. So at last, it will be square root of 2/9. Then now, when look at the question here, exact length. Okay, so that means you will be getting, this is basically square root 2 over square root 9. So square root 9 is 3. So I will write square root 2 over 3. So that's the exact length. Okay, so now question number 10. The complex number u is defined by this expression. First part, express u in Cartesian form, x plus iy. X and y are in terms of a. So from here, u is 3i over a plus 2i. So now since the denominator have I, that means we have to times a conjugate, which is a minus 2i. And then now we have a formula. If a plus bi times with its conjugate, it will be a squared plus b squared. That means the denominator will be a squared plus 2 squared. Numerator, just do expansion. I will get 3ai minus 6i squared. So again, now I squared is minus 1. Okay, this is minus 1. That means when I simplify, I will be getting 6 plus 3ai over a squared plus 4. Okay, and now I split it into two terms. The real and imaginary part, which is 6 over a squared plus 4 plus 3a over a squared plus 4i. So that's the solution of this question. Okay, now find the exact value of a for which argument u asterisk equals to 1 over 3 pi. This u asterisk means that it is the this is the conjugate. Okay, so now we found this as our u. So the conjugate is just to change the imaginary parts to negative. So now to get the argument, right? So then given argument u complex, the u conjugate equals to pi over 3. So when you look at here, this is basically, now let's see the a first. Okay, a is real. Now it is imaginary parts over arctangent of imaginary parts over real parts. That will be the argument. So I will just write arctangent or inverse tangent of negative 3a over a squared plus 4, this is our imaginary part, divided by 6 over a squared plus 4 over the real part, then it will be pi over 3. So obviously a squared plus 4 can be cancelled off, right? Then this inverse tangent can be moved to the other side. Then you will be getting negative 3a over 6 equals to tangent pi over 3. So tangent pi over 3 is square root 3. And the left hand side is negative half a. Then from here, my a is going to be negative 2 square root 3. So that is the a value. Okay. Now part B. First part. On a sketch of an Argand diagram, shade the region whose points represent complex number z, satisfying the inequality, and the other one. So for the first one, z minus 2i, modulus z minus 2i less equals to z minus 1 minus I. So for this case, I have to express in general form, which is z minus 0 plus 2i. For the left hand side, for the right hand side, it will be z minus 1 plus I. That means here I got 2 points. The first point with coordinates 0, 2, and the second point with coordinates 1, 1. Where to get 1, 1 is basically here 1, and this is 1i. Okay, so then the next one, this is going to be the perpendicular bisector. Then the next one is modulus z minus 2 minus I less equals to 2. So the general form is z minus 2 plus I less equals to 2. This is the circle inequality. So the circle with center 2, 1. Okay, because 2 plus I. And then the radius is 2 units. Now here, when we sketch both on the same diagram, I will draw the circle first. Okay, so let's say here is 2. Okay, here is 2, this is 4, 0, 2, 4. Then here is negative 2. Now, center at 2, 1. So, 2, 1, roughly here. Radius is 2. So, you add 2 units from this. Here is 1. Okay, so 1 plus 2, it will be 3. So, this is 3. Here is 4. Right, that means now you'll be getting this point. And then 2 units means that it will be roughly here. 2 radius is 2 units, so 2 units, and here is 2 units. So it means that your circle will be roughly like this. Okay, maybe I just draw a circle and then I label my axis. That will be easier. Maybe you just use a coin to draw the circle. Okay, so we know that this is going to be negative, so here is negative 1, this is 2, here is 4, this is 3. Okay, so this will be my circle, and then another one will be 0, 2. So let's say here is 2, this point, 1, 1. So let's say here is 1. Right, so when you need to sketch this locus, so you join these 2 points first. Right, when you need to measure so that you will get the correct graph. Then you have to find the midpoints of these 2 points. Okay, midpoint. The midpoints will be at this, roughly here. Okay, roughly here. Then you just draw the perpendicular bisector. Right, so this is your modulus z minus 2i equals to z minus 1 minus I. Now, the region, okay, circle, because it's less than 2, less than equals to 2 means that everything inside the circle. And then for this inequality, now this means the distance from the general points to 0, 2 is less equals to the distance from the general points to 1, 1. Here is your 1, 1. Okay, so when I consider this point, right, so this distance from to 0, 2, okay, is shorter than this distance. Or if you are not sure, you just take this. Okay, take this point here. So the distance here is shorter than the distance to the other side. That means your points will be over here. Right, this is how we decide. Okay, so that is the locus of this question. This is going to be the circle equation. Right, so for locus, we don't label xy, but we label real and imaginary. So this is imaginary. And this horizontal axis is real axis. So done for this part. Now, part 2, calculate the least value of argument z for the points in this region. Least value means the smallest value. So it means that the orange color will be the the orange color will be the z. Okay, so obviously the argument always counted from the origin, right? So therefore this is going to be our smallest. This is our least argument. So this least argument happens when it is at 2, 3. Okay, my diagram is not very accurate. Right here, when you calculate, it should be 2. That's why you must draw using the correct tool, because here I only simply sketch. Right, so here this point is basically 2, 3. So which means now when you get 2, 3, okay, here is 3, this is 2. So the argument, right, you can just write here the least argument z occurs at z equals to 2 plus 3i. So to get this argument, so argument z equals to argument 2 plus 3i, which is inverse tangent 3 over 2. Okay, then at last you will be getting 0.983 radians. So this is based on the locus that we have sketched just now. Right, that's why when you sketch our locus, make sure you measure correctly, okay, or use the correct tool to do it. Okay, otherwise you won't get the answer. Okay, so we have come to the end of the video. Thanks for watching. Please subscribe to the channel and recommend it to your friends, and also stay tuned for more upcoming videos. Thank you. Bye.